Today we would like to discuss China's semiconductor industry. It is a topic viewers have been asking us for quite a time. In the past 3 years, the tech war between China and the United States intensified. We need to say there is an enormous gap between China and developed countries. In a previous video, we said China would win the tech war in 5 to 10 years, but it has to progress in many areas. Every year, China spends over $300 billion on imported chips. In 2020, the amount was around $380 billion. China is the world's biggest semiconductor market. Over 40% of chips are purchased by Chinese companies. Huawei is a good example. It buys electronic components from local and international suppliers and sells its finished products to the world. In the past years, the United States banned Huawei in the States and forced its allies to dismantle Huawei equipment and stop procuring its telecom devices. However, there is not even one US company that can compete with Huawei, and the US does not want to lose such a big buyer. As a result, it forbids suppliers worldwide which adopt US technologies to sell components to the world's #1 telecom giant. Still, it approves Intel, AMD, and Qualcomm to supply chips to the Chinese company. Simply put, the US wants to curb China's development, but at the same time, it wants to make money from the world's biggest market exclusively. As the world factory, if it cannot master the semiconductor industry, the US, Japan, and Europe will use its production capacity to make money out of the global market, just as they outsource the pharmaceutical sector to India to reap profits from the patients worldwide. China wants to solve the problem. It has launched various types of semiconductor projects, and has made some progress in certain areas. For example, SMIC announced that it will try to make 7nm chips in the first half of 2021, becoming the third company in the world to master the high-end chip manufacturing process. And Shanghai Microelectronics has developed a photolithography machine that can manufacture out 28nm chips. And a Chinese supplier can also make the world-class photoresist, to name a few only. However, China is competing with the whole world, as the United States uses its capital and patents to control thousands of suppliers worldwide. China can buy oil from Russia, Iran, Venezuela, and other nations, disregarding the US threats. Still, most suppliers in Japan, South Korea, France, Germany, the UK, etc., dare not disobey the mandates from Washington, D.C. As a result, China needs to establish a self-sufficient supply chain for the semiconductor industry. It takes time, and it is also precarious. We can decompose the semiconductor industry into 5 segments. First, silicon wafers are the foundation at present. The production of semiconductors starts from cutting, lithography, and other operations of the wafers. For the wafers, China's self-sufficiency rate is about 75%, a pretty good number indeed. However, it is only a pretty number on the books, and it does not mean that China's real self-sufficiency rate is so high. Many of China mainland's silicon wafer factories are joint ventures. The technology, management, and other initiative control are not considered fully self-sufficient as they are in the hands of foreign investors. China consumes about 45% of the world's chips each year. Still, at this stage, it relies on importing finished chips rather than the domestic purchase of silicon wafers and independently manufactured parts. Samsung, TSMC, Micron, Intel, and other European, American, Japanese, and Korean companies are big players, of which Samsung, TSMC, and Micron monopoly the global silicon wafer production capacity of 60 to 70%. No Chinese company is among the world's top 10 manufacturers of the silicon wafer fab. China's self-sufficiency in silicon wafers, there is still a long way to go. Second, the semiconductor raw materials, primarily auxiliary chemical materials, including photoresists, polishing agents, electronic gases, etc. China's self-sufficiency rate in this field is about 25%. The photoresist used for submerged ArF lithography, the self-sufficiency rate was almost zero, especially in the high-end photoresist area. Japan controls about 70% of world supply, and in the past years, it refused to sell photoresists to Chinese companies several times. The good news is that China masters the core technology to produce top-level photoresists already. very likely, there will be a price war soon. Exposure scribing is the most highly priced chip manufacturing process. And China's self-sufficiency rate of the most essential material, photomask, is 1%. The electronic gas used to maintain the particular environment of chip manufacturing and chip packaging is relatively simple. China's self-sufficiency rate is around 30%. In a word, as China did not spend much on materials science in the past, it takes time for it to self-supply hundreds of raw materials needed for semiconductors. Third, semiconductor manufacturing equipment, still a long way to go. We often hear the photolithography machines. ASML, Nikon and Canon monopoly more than 90% of the global photolithography market. ASML alone accounts for 75% of the lithography market, and in the field of EUV lithography, it is the only supplier and has no competitors. China has overcome the 90 nm and 28 nm DUV lithography difficulties, but the road to commercialization is challenging. China is in a good position in producing the other two significant pieces of semiconductor equipment, etchers and thin film equipment. China's 5 nm etching machines have been used to produce chips for Apple and Qualcomm. China is also working on 3 nm, and the technology level has reached Tier 1 globally. For the thin film equipment, China's self-sufficiency rate is around 2%. In all semiconductor manufacturing equipment, including photolithography, etching machines, thin film equipment, glue leveling machines, developing machines, etc., China's overall self-sufficiency rate is merely 12.5%. In short, China is much behind in semiconductor manufacturing equipment as a whole. Fourth, the semiconductor manufacturing process. The US-controlled TSMC is working on 3 nm, and China mainland has a long way to catch up. As China mainland's most prominent semiconductor manufacturer, SMIC was supposed to produce 7 nm chips. Still, there is no news due to the late arrival of EUV machines from ASML. The US is now tightening the embargo on semiconductor technology and equipment against China. The latest news is that companies that adopt US technologies cannot sell 28 nm machines to China. The semiconductor equipment and semiconductor raw materials heavily depend on Europe, the United States, Japan, and South Korea. China needs to localize them as soon as it can, and it is not easy. Apart from the above four fields, China also needs to focus on the fifth area, developing its EDA software for chip design instead of relying on foreign companies. The good news is that China's EDA software can deal with part of the 7 nm chip designs and all 14 nm and above manufacturing processes. A company specializing in EDA software was just approved for listing recently. We must admit the fact that China mainland's semiconductor industry as a whole is seriously lagging behind Western nations, including Japan, South Korea, and Taiwan, the island China claims to be one of its inalienable parts. China has achieved breakthroughs in some areas, which are not enough to change the big picture yet. There must be a comprehensive breakthrough in raw materials, equipment and processes, auxiliary materials, and EDA platform. Otherwise, foreign nations can still strangle the whole industry at any time. The gap is enormous, but China is catching up. In its 5-year plan from 2021 to 2025, China will realize a 70% self-sufficiency rate in the semiconductor industry. We believe that it is one of China's top strategies to break the bottleneck in the sector, and the cost and profits are the last things to consider when implementing it. Just like the high-speed rail lines, China does not care whether they make money or not in 10 or 20 years. Samsung, TSMC, ASML, and other foreign companies are indeed giants in their fields, respectively, but when China wants to do something, no country or company can stop it. Early today, China just sent 5 satellites to their orbits with 1 rocket. And we believe in 3 years, it can record more breakthroughs in the semiconductor area. In March 2021, China started an industrial park called the Eastern Chip Port in Shanghai, and invested nearly ₹500 billion RMB. 216 projects have been finalized, and 16 of them are related to chip manufacturing. In a previous video titled, "Do Not Force China to Fry Chips," we anticipated a price war soon. When China catches up, the market will be reshuffled big time. Share your opinions below, whether you agree or disagree with us.